Okay, what's up guys? Welcome back to the Math Mastery YouTube channel. Today we're gonna be looking at how to find the x-intercept, right? So first of all, the first thing we need to understand is what is the x-intercept, right? So the x-intercept is the point at which a function touches the x-axis, right? It intercepts with the x-axis, hence why it's called the x-intercept, right? So if I have a parabola, for example, and it looked like this, the x-intercept, or in this case, this x-intercepts, right, because it's two, would be here and here, right? So um, that's what the x-intercept is, right? It's the point where the graph touches the x-axis, right? So as we notice here, when the graph touches this x-axis, right, the y value is zero, right? At this point, the y value is zero, right? So in order to find the x-intercepts, our first step is to make y equal to zero, right? So for example, let's say I have some quadratic. So let's just say I have x squared plus 7x plus, I don't know, let's just say 12, right? Let's say I have this quadratic and I want to find the x-intercept, right? So the first step is to make this equal zero, right? So we'd say for x-intercept, let y equal zero, right? So we let y equal zero, right? So we have x squared plus 7x plus 12 equals zero, right? That's our very first step. Now from this point, there's two ways we can do it, right? Either we can factorize or we can do the quadratic formula, right? So in this video, we'll look at both, but we'll start with the factorizing method, right? So how we can do this is we can factorize this left-hand side, right? So factorizing this, we get x plus 4, x plus 3, right? The reason for that is we need to find, so in order to factorize quadratics, right, what we do is we find two numbers that when we multiply them, we get 12, and we add them, we get this b term here, right? So I won't go into too much detail. I'll maybe save that for another video, but if you're unsure on this step, I'll perhaps do it on another video, right? But so far, hopefully this makes sense, right? So from this point on, we can do the null factor theorem, right? So the null factor theorem states that if I have, I guess, two terms multiplying, right? So if I have a, b, right, a times b equals zero, one of these has to be zero, right? Otherwise, it doesn't make sense, right? There's no way we can have two things multiplying to equal zero without one of them being zero, right? So what ends up happening is, by null factor theorem, either x plus 4 is zero or x plus 3 is zero, right? And then we, I guess, solve these separate cases, right? So in the first case, x is minus 4. In the second case, x is minus 3, right? So then we got our intercepts are negative 4 and negative 3, right? And we found the x-intercepts, right? So on a graph, sorry, this will look something like this, right? So if we graph this, it would be like this. So we'd have y-intercept here, then we have negative 4 and 3, right? So it look like this, maybe, right? That's not the best drawing, but I think you get the idea, right? This would be intercept 12. This would be negative 4, negative 3, right? Those are intercepts, right? So this is one way we can find the x-intercept or x-intercepts by factorizing, or the other way is the quadratic formula, right? So you should know the quadratic formula. I went through that in another video, the proof for that. But if you don't know the quadratic formula, looks like this. Right, so x equals minus b plus or minus the square root of b squared minus 4ac. Right, so doing the quadratic formula, we just sub in our a, b, and c terms into this formula. Right, so our a term is just 1. So a term is the number outside of the x squared term. So that's just 1. There's nothing here. The b term is 7 and the c term is 12. So we sub that in here. So we're going to get minus 7 plus or minus the square root of 7 squared minus 4 times 1. That's a times 12, right? So if we do this, and then on the bottom it's 2 times 1, right? So just 2. So we're going to get x equals negative 7 plus or minus 49, that's 7 squared, and then minus 4 times 12, which is 48, right? So that's just 1. So we get x equals minus 7 on 2 plus or minus 1 on 2, right? So we're going to get x equals minus 8 on 2, right, which is minus 4. Or we're going to get x equals minus 6 on 2, right, which is minus 3, which is the answer we got before, right, minus 4 and minus 3, right? So those are two ways to find the x-intercept using either quadratic formula or factorizing. So both of these answers, or both of these methods, sorry, will get you the correct answer. Which one to use? I guess it depends on a few things on personal preference, right? Some people just like to plug it in this, right? There's less kind of, I guess, possibilities of error, right? Here you just, plug it in, right? And you simplify here because there's a few more steps you got to factorize. Maybe if you factorize it incorrectly, you're gonna get the wrong answer. So I guess there's more risks of getting it wrong. There's more risks of messing up here. But I guess it depends on kind of the how complex the quadratic is, right? For this one, we can kind of factorize this. It's pretty simple, right? We can do it in our head. And that will be much more easier, right? You could factorize this in your head and you'd know the intercepts immediately, right? But with something more complex, right? If I had like, say for example, I had something like this, like 2x squared plus 18x plus 31, right? This is something more complex, right? And you'd probably want to use the quadratic formula for this, right? And some quadratics we can't factorize, right? We can't factorize simply like this, right? So in those cases, we'd want to use quadratic formula, right? But yeah, that's how to find the x-intercept. Hopefully that video made sense. And yeah, don't forget to like and subscribe, and I'll see you next time. Bye.